Okay, how are we all doing? So this is module 1 of switching, routing and wireless essentials, and so it's basic device configuration. So it's a bit of a rehash on CCNA 1, but anyway. All right, so we're going to look at how to configure a switch with initial settings. We're going to look at configuring switch ports, securing remote access, then we'll look at basic router configuration and verify directly connected networks. So, initial settings for a switch. So after a Cisco switch is powered on, it goes through the following 5-step boot sequence. So first it does what's called post or power on self-test. So that program is stored in ROM, and so it actually checks to make sure that all the required hardware is there and it's working. So CPU, RAM, flash, other such things like that. So after that has completed, next the switch loads the bootloader software. Bootloader is a small program stored in ROM again that's run immediately after the post. So the bootloader performs a low-level CPU initialization, initializes the CPU registers which control where the physical memory is mapped and quantify the memory and its speed. The bootloader initializes the flash file system on the boot system board. Finally, the bootloader locates and loads the default iOS operating system's software image to memory and gives control of the switch over to the iOS. Okay, so the switch attempts to automatically boot by using information in the boot environment variable. If this variable is not set, the switch attempts to load and execute the first executable file it can find. iOS operating system then initializes interfaces using iOS commands found in the startup config file. The startup config file is called config.txt and is located in Flash. In the example, the boot environmental variable is set using the boot system global command. And notice that iOS is located in the distinct folder and the folder path is specified. Use the command show boot to see what the current iOS boot file is set to. So here, basically, you've got the command boot system, and then on this file system, in this directory, and then this file. Okay, so on a switch, there's some LEDs that tell you the status of different things. And so there's a system LED, which shows whether the system is receiving power and functioning properly. The colour of that will, and whether it's flashing or not, will tell you that. It will also tell you if there's a redundant power supply connected. So in other words, if your 240 volts drops off, it can actually run from your RPS and give you some reliability. And then there's port status LED. When green indicates the port status mode is selected, which is the default. And so then from there, if you actually hit the mode button, it will actually change over to indicating, so initially it's just your status mode, which of course is stat, then it will show you a different color code for full duplex, and then it will, if you hit the mode button again, it will then show you the speed setting, speed that each port is running at, and it will also give you a status of power over Ethernet for each port that's there. And so basically that mode changes what each port's lights actually indicate. All right, so the LEDs with the remote power supply, redundant power supply. So if there's no LED, it means there's no redundant power supply. If it's green, it means it's ready. Blinking green means it's up but not available. Amber means standby or fault. Blinking amber means there's an internal power supply failed and the RPS is providing power. And so with PoE, not selected, no issues, selected, and so from there, blinking green, the only thing that has a meaning is blinking amber, which means not selected, port issues present. When it comes to the status, basically, if there's no LED, it means it's off. Green means the link is up. If it's blinking green, that means there's traffic moving on that port. If it's amber, it means the port has been blocked to preventing the loop, so that's spanning tree protocol. Blinking amber is, again, means the port is blocked and preventing a loop. And then if it's alternating green and amber, means there's a fault on the link. Duplex basically means if it's off, it's half duplex. If it's green, it's full duplex, and that's the only setting. And so, so when it comes to speed, if it's off, it means it's 10 megabits. If it's green, it's 100 megabits. If it's blinking green, it's 1,000 megabits. And PoE basically is it's either off or on with the off or green, and then there's amber if it's been disabled. Blinking amber if it's off due to a fault, or PoE denied over budget, so in other words, it's too many ports using power. Okay. So how do we recover from a system crash? So the bootloader provides access into the switch if the operating system cannot be used because of missing or damaged system files. Bootloader has a command line that provides access to the files stored in flash memory. The bootloader can be accessed through a console connection following these steps. So connect the PC by console cable to the switch console port, configure terminal emulation software to connect to the switch, you unplug the switch power cord, then you reconnect the power cord to the switch, and then within 15 seconds press and hold the mode button, which is the one we saw in the picture earlier, while the system LED is still flashing green. You continue to press the mode button until the system LED briefly turns briefly amber and then solid green. Then you can release the mode button, and then you'll basically into bootloader mode. And so you'll get a switch : prompt on your console. And the bootloader command line supports commands to format the flash system, reinstall the operating system, and recover a lost or forgotten password. For example, the dir command can be used to list all of the files within a specified directory. So that's actually, if someone does trash iOS, that this is the most common reason that I've gone to this mode, is to actually then use X modem to transfer a file to the switch. All right. So switch management access, and so of course you can do it off. So basically, to prepare a switch for remote management access, the switch must be configured with an IP address and a subnet mask. So to manage the switch from a remote network, the switch must be configured with a default gateway. This is very similar to the IP configuration on a host. In the figure, the switch virtual interface on S1 should be assigned an IP address. And so you do that, you don't do physical ports. And of course, the console cable is used to connect to the PC so that the switch can be initially configured. So it's basically, it's out of band using the console cable or in band using a network connection. Come along. Thank you. So by default, the switch is configured to have its management controlled through VLAN 1. All ports are assigned to VLAN 1 by default. For security purposes, it's considered best practice to use a VLAN other than VLAN 1 for the management of VLAN, just to make it different, make them extra information they need to find out. That's hackers, that is. So you configure the management interface. From VLAN interface configuration mode, an IP address and subnet mask is applied. Of course, you then need to turn it on. Note the switch virtual interface of VLAN 99 will not appear it was up and up until VLAN 99 is created and there is a device connected to a switch port associated with VLAN 99. Switch may need to be configured for IPv6, for example, before you can configure IPv6 addressing on a Catalyst not 2960, you need to have version 15 of iOS, and you will need to enter the global config mode and actually turn it on. Basically, you need to put it into a different mode. So SDM is switch device manager. And yeah, then you need to reboot the switch, and then IPv6 will be available. Okay, and so how do we configure the IP address? And so, of course, we're in privileged exec mode there. Configure terminal will get you into global config mode. Then you need to be into interface configuration mode for VLAN 99, so hence that command. As you'll notice, the prompt has gone from global config mode to interface mode. And then you do the IP address command with a mask. You can do an IPv6 address command with a prefix. Then, of course, you need to turn the interface on, and that is done. That will set an IP address, but of course we haven't set a gateway yet. So, so the switch should be configured with a default gateway if it will be managed remotely from networks that are not directly connected. You don't need to do this for IPv6, of course, because a router advertisement will actually come through. And so you only need to set it for IPv4. And so that's in global config mode, IP default gateway, and away you go. All right. So how do we verify that it's working? So show IP interface brief is a very quick way to do it. And so of course it tells you the interface is VLAN99, gives you the address, and gives you the status. So status down, protocol down is not good. It's not working, but at least you're getting an idea. So it confirms it's been configured. An IP address applied to an SVI is only for remote management access to the switch. This does not allow the switch to route layer 3 packets. Okay, so how do we configure switch ports? So I'm going to say when it comes to Ethernet, there's a few settings you need to do, or you can do, you don't have to. So full duplex, of course, is where you've got a choice between half and full duplex. Full duplex, of course, is the more desirable of the two, and so it increases bandwidth efficiency by allowing both ends of a connection to transmit and receive data simultaneously. So it's bidirectional communication. It requires microsegmentation. A microsegmented LAN is created when a switch port is only one device connected and is operating in full duplex mode. There is no collision domain associated with a switch port operating in full duplex mode. Unlike full duplex, half duplex communication is unidirectional. Half duplex communication creates performance issues because data can flow in only one direction at a time, often resulting in collisions. So gigabit Ethernet and 10 gig Ethernet require full duplex connections to operate. Full duplex mode, the collision detection circuit on the NIC is disabled, and so it offers 100% efficiency in both directions. It results in a doubling of the potential use of the stated bandwidth. You've got 100 or 1,000 or 10,000 megabits in each direction. All right, so how do we configure the physical layer? Switch ports can be manually configured with the specific duplex and speed settings. The respective interface commands are duplex and speed. So the default setting for both duplex and speed on the switches is auto, which means it will auto-negotiate with the other end of the cable. And so gigabit ports, of course, can support 10, 100 or 1,000. And so basically the two devices will negotiate the highest speed they both support. And of course, they will also negotiate whether they support full duplex or half duplex. And so of course, full is the more desirable. So auto-negotiation is useful when the speed and duplex settings of the device connection to the port are unknown or may change. When connected to known devices such as servers, dedicated workstations, network devices, the best practice is to manually set the speed and duplex. When troubleshooting switch port issues, it is important that duplex and speed settings are checked. Mismatched settings for the duplex mode and speed of switches can cause connectivity issues. Auto-negotiation failure creates mismatched settings. All optic fiber ports such as 100 base SX operate only at one preset speed and are always full duplex. Of course, fiber optic is two cables, it's not a problem. Two fibers. Okay, so basically to configure the ports, you can do duplex full, speed 100, all good. And that is the way that you would manually set them. Now, MDIX, of course, is media-dependent interface crossover. And so auto MDIX means that, again, you can basically sense what the other end is using and adjust accordingly. So when connecting to switches without the auto MDIX feature, straight-through cables must be used to connect to devices such as servers, workstations, or routers. Crossover cables must be used to connect to other switches or repeaters. With auto MDIX enabled, either type of cable can be used to connect to other devices, and the interface automatically adjusts to communicate successfully. On newer Cisco switches, the MDIX auto configuration command enables the feature. That is on by default. When using auto MDIX on an interface, the interface speed and duplex must be set to auto so the feature operates correctly. Note that auto MDIX feature is enabled by default on Cisco and Catalyst 2960s and 3560s, but is not available on older Catalyst 2950s and 3550s. To examine the auto MDIX setting for a specific interface, do show control as Ethernet, and it will actually tell you there'll be a fire keyword, and then to limit the output of lines reference, you can actually just include auto MDIX filter. Okay, so other switch verification commands. So show interfaces shows you all the interfaces on the switch. There's a lot. show startup config, show running config, show flash, show version. So of course they share the config, whether the active one or the backup one. Flash shows you what's the contents of the flash drive. Show version tells you what version the operating system is running, as well as hardware as well. Show IP interface, show IPv6 interface, because it gives you the IP information. And then show MAC address table, of course, is for the MAC address table, which of course is what the switch uses to forward frames. Okay, so how do we configure, verify switch port configuration? So show running config. And so of course you can actually have a look through. Of course there's going to be lots of ports, because that's the whole point of switches. And so of course, apparently we've got fast Ethernet 018 configured with management VLAN 99, and we've also got the switch virtual interface of VLAN 99 with an address, or two addresses, and then we've got a default gateway. Now, show interfaces command is another commonly used command which displays status and statistics information on the network interfaces of the switch. Show interfaces command is frequently used when configuring and monitoring network devices. The first line of the output of the show interfaces command indicates that the switch, the Ethernet 018 is up and up, meaning that it's operational. So basically, the first one means the physical layer is up, the second one means the data link layer protocol is up. Further down, the output shows that duplex is full and speed is 100. And so, yeah, full duplex 100 megabits. Okay, network access layer issues. The output from the show interface command is useful to detecting common media issues. One of the most important parts of this output is display of the line and data protocol status as shown in the example. Like I said, the first parameter refers to the hardware layer, so physical layer, and indicates whether the interface is receiving and carrying a detect signal. The second parameter, line protocol, refers to the data link layer and indicates whether the data link layer protocol key loss are being received. Based on the output, the possible problems can be fixed as follows. So if the interface is up and the line protocol is down, the problem exists. There could be an encapsulation type mismatch. The interface on the other end could be an error disabled, or there could be a hardware problem. If the line protocol and the interface are both down, the cable is not attached typically, or some other interface problem exists. And so if you've got hooked into another router or a switch, that could be administratively down as well. If the interface is administratively down, it means it's been turned off with a shutdown command, and so to get it up, you need to do no shutdown on that interface. Okay, show interfaces gives you basically a screen full of information for each interface, as you can see here. So you can see the status that it's up. You can see the duplex and speed. Now you can actually see some statistics. So the reliability has been 255 out of 255, so there's been no errors. Transmit and receive load is 1 out of 255, so that means it's not very busy at all. And yeah, so that's some good information. There's been very few errors, been 3 input errors, 3 CRCs, and so 0 runts, 0 giants. And so output errors, there's been 790 collisions, 10 interface resets, 235 late collisions. Ooh, there's a bad wire in there somewhere. Now, so input errors, the total number of errors that includes runts, giants, or no buffer, CRC, frame, overrun, or ignored counts. Runts means that they're frames smaller than 64 bytes. Giants means they're frames larger than 1518 bytes. CRC errors, of course, are the checksum has generated errors. Output errors, sum of all errors that prevented the final transmission of datagrams out of the interface. Collisions, number of messages transmitted because of, retransmitted because of Ethernet collisions. And then late collisions it's actually after the first 64 bytes or 512 bits. And that means that is what actually tells you that there's a fairly large problem on that network, and one of the possibilities is you've got a long cable. Of course, it's probably running in half duplex mode as well. All right. So run frames, Ethernet frames that are shorter than 64 byte minimum allowed. Malfunctioning NICs are the usual cause of excess run frames. Giants are larger than the allowed size, and then CRC errors means that there's been some kind of interference and the data has been modified in transits, typically through noise or interference. Just, the signal is weakened and you can't read it. Output errors is the sum of all the errors, and so, yeah, we've pretty much covered that. All right, so troubleshooting network access layers. So perform a show interfaces. Is the interface up? Yes. Are there indications of inline noise? If yes, remove sources. Verify the duplex setting is properly set on both ends. And is the problem solved? Yes, all good. Or no, document the work and escalate the issue. So if the interface is down, verify that you got the cables in and they're the right ones. Check the cables and connectors with damage. Verify speed is properly set on both ends. So again, so that's basically a troubleshooting flowchart. Okay, secure remote access. Now, Telnet is how we've done most of our access up until now. Now, Telnet uses TCP port 23. It is an older protocol that uses unsecure plain text transmission for both login authentication and also the data that's transmitted. So a threat actor can monitor packets using Wireshark, for example. In the example, the threat actor captured the username admin and the password CCNA from a Telnet session. And but Wireshark is very nice. It actually shows you what it would look like. So that makes it very easy for a hacker. So the preferred option is Secure Shell. And so it's a secure protocol that uses port 22, provides a secure encrypted management connection to a remote device. It should replace Telnet for management connections. SSH provides security for both remote connections by providing strong encryption when a device is authenticated, so username and password, and also for the transmitted data between the communicating devices. The figure shows a Wireshark capture of SSH session. The threat actor can track the session using the IP address of the administrator device. However, unlike Telnet, the SSH with SSH, the username and password are encrypted, including everything else. See a whole lot of SHA, which of course is your encryption. Okay, so how do we verify that your switch supports SSH? So typically these days it's K9. If it's an older version, if it's got K7, it did as well. But yeah, K7 I think means it supported SSH only. K9 it supports several forms of encryption. So use a show version, and as long as the version number has got the K9 in it, you should be good. Okay, so how do we configure it? Now SSH is not on by default, mainly because there's a bit of housekeeping you need to do first. So basically, you need to configure a host name. You also need to have a IP domain name. So in other words, it actually needs a fully qualified domain name for SSH to work. So, router1 .flinders.edu.au or something like that. And so basically, once you've configured both the host name and the domain name, and of course that iOS supports it, you then need to create key pairs. And so, RSA are, of course, the first initials of the people who invented it. Ravi, I can't remember who the other one was. Use the crypto key generate configuration mode command to enable the SSH server on the switch and generate an RSA key pair. So basically, it uses asymmetric encryption, which basically means you encrypt with one key and you decrypt with the other. So they have a mathematical relationship with one another. And so if you encrypt with the public key, which is one of the keys, which is given out to all the hosts that connect, and then only that switch or router can decrypt that information when it is being transmitted, because the only device that has the private key is the switch or router. So you then, of course, need to create some user authentication. So you actually need a local user database at the very minimum. And so you can actually do a username password command to actually create a username and password combination. And then you need to configure that the VTY lines use SSH, and preferably, probably only SSH, just so that they can't use Telnet. And then also version 2 of SSH is better because there was a couple of flaws in version 1. There's going to be an example. Okay, so on a PC, an SSH client such as PuTTY can be used to connect to an SSH server, for example. So SSH is enabled on switch 1, it's got that IP address, and the PC1's got that address. So using a terminal emulator, you can actually connect to that. And so, of course, you can use username admin, the password of CCNA, apparently. After entering the correct combination, the user will connect via SSH to the command line interface. And so, as you can see, you get the prompt there. So, there's a show IP SSH command. It shows you that we're running version 2. And this show SSH actually shows you what sessions are active at the moment. And so, it's admin is the user that's using it. Okay, basic router configuration. So here we go. So, of course, with a router, you need to set the host name, enable secret password, console password, VTY passwords, and service password encryption, of course, stops people from seeing the password when they see the config. A banner mot D is always a good idea. Message of the day, that is, and so authorized access only is another good idea. So, of course, once you've done those changes, you should save it to the startup config. So copy running config to startup config, and so that saves your changes, basically. All right, now, of course, we're going to do a dual stack topology. And so one distinguishing feature between the switches and routers is the type of interfaces supported by each. For example, layer 2 switches support LANs, therefore they have multiple fast Ethernet or gigabit Ethernet ports. The dual stack topology in this figure is used to demonstrate the configuration of an IPv4 and IPv6 interfaces. So here we go. So we've got these IPv4 and IPv6 networks here. So there's a total of 5 networks because there's 4 Ethernets and 1 serial. Okay. So configuring router interfaces. Routers support LANs and WANs and can interconnect different types of networks, therefore they support many types of interfaces. For example, G2 ISRs have 1 or 2 integrated gigabit Ethernet interfaces and high-speed WAN card interfaces, HWIC, to accommodate other types of network interfaces, including serial, DSL and cable. So to configure an interface, you need to have at least one IP address, and so of course IP address is IPv4, IPv6 address is obviously IPv6. And then, of course, you need to turn it on by using the no shutdown command. And optionally, you can put in a description just so later you can be reminded, or someone else can actually see the interface and get a description of what it does. Okay, so here's an example of some configuration. So gigabit 000, it's got an IPv4 address of that, an IPv6 address of that, it's got a description, and of course no shut turns it on. And so then we've got the G001 and we've got S000 here, again with these descriptions. Okay, now loopback interfaces. So another common configuration is enabling a loopback interface. So it's not the same as what we talk about in loopback with hosts. And so it's a logical interface that is internal to the router, is not assigned to a physical port and can never be connected to by to any other device. So physically connected, that means. It's considered software interface that is automatically placed in an up state as long as the router is functioning. Loopback interface is useful in testing and managing a Cisco IS device because it ensures that at least one interface will always be available. For example, it can be used for testing purposes such as testing internal routing processes by emulating extra networks. So loopback interfaces are also commonly used in lab environments to create additional interfaces. For example, you can create multiple loopback interfaces on a router to simulate more networks for configuration practice and testing purposes. The IPv4 address for each loopback interface must be unique and unused by any other interface. In this curriculum, we often use a loopback interface to simulate a link to the internet. And so to create one, you just do interface loopback and then 0, 1, however many. Then you can set an IP address, and it will be up automatically. You don't need to do no shut because it's up as soon as you do it. So how do we verify directly connected networks? So there are several show commands that can be used to verify the operation and configuration of interface. So there's show IP interface brief and show IPv6 interface brief. These display a summary for all interfaces, including IPv4 and IPv6 addresses and their current operational status. So show running config of interface and its ID just shows the commands for that particular interface. Show IP route or show IPv6 route, of course, shows you the routing table for for those routed protocols. So, show IP interface brief, of course, gives you one line per interface, and so you can see the IP addresses for each one, you can see their status, and so that's physical layer, that's data link layer. You can see this interface is administratively down, so that means there's a shutdown in that. It also hasn't been configured at all. Show IPv6 interface, of course, gives you a link local address as well as the global unicast address. And again, S011 is unassigned. Okay, so show IPv6 interface brief. We already had a look at that. And so you can also do show IP interface gigabit Ethernet 000, and that will display some statistics about it as well. And it even tells you what multicast groups it's listening to. Okay, so with the show running config interface command, you can actually just look at a particular interface. So as you can see, it just gives you that interface's configuration. Don't think it works on packet tracer though. So verifying the routing table, so show IP route. Again, we've just got the IPv4 routes here, and so it's the Cs we normally worry most about because they're the connected networks, and so they're the three directly connected. And so of course with IPv6, again, the Cs are what we normally worry about. Now, so as I said, the C next to a route with the routing table indicates that it's directly connected to the network. When the router interface is configured with a global unicast address and in the upper state, the IPv6 prefix and prefix length are added to the routing table. And so you can also see the L links, which is local link, and so of course that is the host address of that particular interface. Okay, you can filter show command output. So commands that generate multiple screens of output or by default paused after 24 lines. At the end of the paused output, the more text appears. Pressing enter displays the next line. Pressing spacebar shows the next 24 lines. You can use the terminal length command to specify the number of lines to be displayed. If you put 0, it won't pause between screens. Of course, other than that, you can verify and modify the size. Another very useful feature that improves the user experience is filtering of show commands. So filtering commands can be used. And so here you can actually just have things like include section or include, interface such and such or section such and such and begin and things like that. So again, I'm not sure if this works on packet tracer. I haven't tried it recently and it's a new version out, but anyway. There is also the command history feature, and so you can use the Control P for previous or up arrow to see the previous commands and keep going. Control N, of course, will scroll you down the list as well as the down arrow. I've got a minute, I just use the arrow keys. You can do show history. It'll show you the last 10 by default. It's also practical to increase the number of commands by doing the terminal history size command. And so you can increase the size to more than 10. Okay, that's the end of the chapter. So we have looked at what today. So there's, after Cisco switch is powered on, it goes through a 5-step boot sequence. So the boot environment variable is used to set the boot system configuration command, mode command. You can use switch LEDs to monitor switch activity and performance. So the system, redundant power supply, status, duplex, speed, and power over Ethernet. The bootloader provides access into the switch if this operating system cannot be used because of missing or damaged system files. To prepare a switch for remote access, the switch must be configured with an IP address and a subnet mask. If you need to access it from a remote network, you need to tell who its gateway is. So full duplex communication increases effective bandwidth by allowing both ends connection to transmit and receive at the same time. Switch ports can be manually configured to specify duplex and speed settings. Auto negotiation when the speed and duplex settings of the device connected to the port are unknown or may change. There's MDIX as well, which of course detects what kind of connection is required to talk to the host at the other end, or the device at the other end of the cable. There are several show commands you can use to verify switch configurations. Telnet uses port 23, it's unsecure and it's older, and so it's susceptible to being intercepted. While SSH uses port 22 and it encrypts everything, and so the data can be intercepted, but it's meaningless to them unless they know what the key is. An iOS file name that includes the K9 means that it supports cryptographic features, and so SSH will work. To configure SSH, you must verify the switch supports it, configure a fully qualified domain name, you generate the key pair, and then you can configure it to be used on V2R lines and also get it to use version 2. To verify the SSH is operational, show the show IP SSH command. The following initial configuration tasks should always be performed. Name the device to distinguish from other routers, and configure passwords, configure a banner to provide legal notification of unauthorized access, and save the changes on the router. Okay. So one distinguishing feature between switches and routers is the type of interface is supported by each. Routers support LANs and WANs and can interconnect different types of networks, therefore they support many types of interfaces. An IPv4 loopback interface is a logical interface that is internal to the router. It's not assigned to a physical port and can never be connected to any other device that physically connected. Use the following commands to quickly identify the status of an interface. So show IP interface brief or IPv6 interface. Show running config, and you can actually specify the interface name. Show IP route or show IPv6 route, of course, shows the routing tables. Filter show command output using the pipe character. Use filter expressions section include, exclude, and begin. By default, command history is enabled, and the system captures 10 last command lines in its history buffer, and so you can use the show history command to actually see what's in the buffer. Of course, you can use the up and down arrows to move through the buffer. That's the logo, so that's it for chapter 1. So I'll see you again later for chapter 2. Have a good one.